Hello everybody. Today I want to talk about custom events. Actually, this is a continuation from a couple previous videos I've done. The one before this, I talked about the custom event or the .NET event model, processing model. Okay, and there we learned about custom events, event args, how to extend the event args class, what a delegate is, how to create a delegate type, how to then use that delegate type to create an event in the class or to declare an event, and then how to make a publisher that actually generates the event, and how you could write a method that triggers the event. Okay. And then how to, take a subscriber and have an event processing method that conforms to that delegate signature and then subscribe to the event. And then when that event fires or triggers, the event processing method or the event handler method, carries out its actions, right? Today I want to take that a little bit farther. In this example, I want to talk about an app called Automated Water Tank System. And what I'll do is I'll run it to show you how it works, and then I'll go through the code. This is a rather complex application, so I won't be doing a lot of coding. I will bring up the code and explain how it works. You can download this code off the website, pulpfreepress.com. Go to the C# for Artists 2nd edition support site, and you can download the zip file with all the code. And I'm going to give a shameless plug for the book, C# for Artists, 2nd edition. It's a great book. If you haven't already picked it up, go ahead and grab it off the website. $15. It's only available in PDF. But if you're struggling to learn these concepts, I think you can't go wrong. Okay, so let's return to the custom water tank example. All right, let's go to Windows 10 here. I've got a command prompt pull up. So let's see here, system app. So this is a combination of a I gotta grab it here. Hang on. Let's run that again. Okay. Let me make it bigger. There we go. Having trouble grabbing it. Okay. It's a combination of I'm writing output to the console so you can see how it works. All right. So we have this area right here where I'm clicking, and you see the halo represents a tank. So there's an add water button. So when I click this button, I'm going to add water to the tank, and you'll see the blue like this, right? It goes up, and then you'll see I've added 1,000 gallons, 2,000 gallons. So in the code, I can control the flow rate. There's a pump. There's water level indicators at the low level and the high level of the tank. Like down here's the low level, here's the high level. I didn't put those in the window, okay, but they're in the code. And so what they do is, as I add water, the indicators are monitoring the level in the tank, and then you saw that as soon as it gets to a certain set point, it will drain the tank, okay? Like that, right? So it's nice to look at. Boop, and the tank drains. Okay, there we go. All right, so let's take a look at the code. I want to step through the code, all right? So bring up the folder with the source code. All right, so the components that make up, or I should say the source files that make up this application are the pump, water level event args, okay, water level event handler. So the water level event handler is the delegate. The water level sensor is just one of the components of the program. The water system app is the executable, or the main application piece, okay, that puts everything together. And then I have a class called water tank. If we go back to the book, this example comes from chapter 13, page 380. There is a diagram here. Let me see if I can fit it. There we go. It's figure 13-5 water tank system UML class diagram. So the water tank is really the big the big class. All right, let me scroll up a little bit. These are diamonds down here, right? So that means it contains a pump, okay? And it contains a water level sensor, all right? Now it can contain, actually, if we look at this diagram, it can contain one or more, all right? And the same with the sensors, although I didn't put that on the UML diagram, but I'm pretty sure there's a low-level sensor and a high-level sensor. And we'll go through the code. In fact, we could probably see it in here, but that text is pretty small for the screen, so we'll run through the code and see how it's all put together. Okay, then we have the pump, all right? The pump class, the water level sensor class. There's an enumeration that represents the mode that the pump's running in. It can run in either high-level indicator or low-level indicator mode. And then we have the water level event handler delegate. Okay, it's got an adornment on the class that shows it's a delegate. Excuse me. Water level event args. This is how we pass in the water level whenever an event fires. Okay. All right, and then we have, of course, the water system app, which is just the main application. Okay, let's go back to the code. Now, I will start, I guess, with the water tank. Let's start with the water tank, because that should be the biggest class here. So we're using system.drawing and system-windows.forms, and water tank extends panel. Okay, water tank extends panel. It has two water level sensors. Okay, so it has a high level, well, one I'm using as a high level sensor, the other one I'm using as a low level sensor. Okay, and then I have a pen, right, to set pen colors when I actually do the animation. I'm not going to go into the animation of the water. Quite honestly, I didn't put a lot of effort into that animation. My goal for this program was to focus on the custom events and the wiring the events and show you how they could be used in a simulation program. And then I've got, and that's the same with pin width. In fact, I think the only editing I'll do here probably is line up some of this code that's poorly formatted. Sorry about that. Oops. Always a chance of making a mistake when you're editing. Then I have a couple integers where I've got current water level, last water level, and tank capacity. I have points. Again, this is to help render the tank in the GUI. Then I have a pump. All right, it's pump. And then I have a graphics, which I use for graphics content. So the most important pieces are the pump here, okay, and then the two water level sensors. And then I have a couple constants in order to help with the drawing. Well, I've got the tank capacity, and this is important for the functioning of the tank. The rest is for the rendering of the user interface. So I'm setting my tank capacity to 10,000 gallons. Well, 10,000, right? It's in gallons. It could be in anything, right? It's just 10,000 things, units, right? Gallons is just something. Since I live in the United States, I think in terms of gallons. It could be 10,000 liters. But when you're writing a simulation, then you would want to do the research and make sure that if this is modeling, if this is code that's running real pumps, right? It's all just running animation. You'd want to make sure that if it is controlling a pump, that you'd have the pump capacity, the flow rates of the pumps, right? If you're writing firmware for pumps. Okay, excuse me. So now I've got a few properties, all right? Actually, I'm going to move. Well, that's fine. I'll leave it like that. This code's not the perfectly formatted code. Okay, property water level, where I just, it's a read-only property. I return the water level. I return the fill rate. Okay. Now the pump, when we go into the pump, you'll see that when I create a pump, I give it a pumping capacity. All right. So the pump has some smarts built into the pump class as well. Now for the water level sensors, so remember this is my containing class, or my aggregate class. So this aggregate class has, 3 components. It has 1 pump and it has 2 water level sensors. Okay. When I set the high point, I'm using the high level sensor, and I'm going to set the point. Okay, to get the set point. If I'm setting the high set point, then I'm just calling set point and setting the value. Right, high level sensor dot set point equals value. So this is the property to set the high set point, or read and write the high set point property on the water tank. Now, if I to set read and write the low set point property, I have a low set point property here. I return, to read it, I return low level sensor set point. All right. Now, constructors. I have a water tank constructor, and it takes some of this is for drawing, X and Y for the upper left, and then the width and the height, so I can set the bounds. I have a tank capacity and a pump capacity. So I can set the tanks, how much the tank can hold, and how much the pump can pump. All right. Then I call this initialize components, and this is where I do a lot of my drawing. I initialize my graphical user interface components down here in the code. I'll just clean that up. It doesn't look that great. Okay. Control save. Now, the default constructor, if I just use the default constructor, it uses the constants that I've declared up above, up here, uses these constants in order to just say, all right, this, which is going to then call this constructor. This is an example of constructor chaining, right? Or I'm calling the default constructor. The default constructor then just calls this constructor with some default values that I've created as constants in my class. Upper left corner, upper right corner Y, width, height, tank capacity, and pump capacity. So I'm setting my tank capacity to 10,000 and my pump capacity to 1,000 units. Initialize components method, I go ahead and set the bounds, right? Do some graphics, and then I get into tank capacity. I set the tank capacity, and then I set the current water level to empty. All right. Now empty. So I go up here, empty equals 0, right? So setting that to empty. Notice how, I've used these constants in order to make the code a little bit easier to read. I could have set water level to 0, but, empty says, whatever that might mean in the context of my program. All right, its pump, and this is where I create the water pump. Its pump equals new pump this. So I'm telling it, what water tank it's associated with. This pump capacity. And then this is concerning some drawing down here. Next piece of code is high level sensor, right? I deal with the high level sensor equals new water level sensor. So I create the water level sensor and I give it a tank capacity minus pump capacity. And I'm doing that calculation for a particular reason, which if we go look at the water level sensor, well, it's the high level sensor. So I'm just minusing from 10,000. I'm going to set the high point to 9,000 essentially at this point. And you can set it whatever you want. I just did it so before, in other words, before the tank gets all the way full, this thing will trigger, right? So I just set it at the tank capacity minus the pump's capacity. And the initial state empty. That's the high level sensor. And then the low level sensor, I set it at the pump capacity, all right, and empty. Now when we get into the water level sensor, we'll see what this is doing. low level sensor mode, and then I set the mode, right? Water level sensor high level indicator. So water level sensor dot mode high level indicator. Then I go down here and I say high level sensor dot fill, all right, plus equals new water level event handler, right? Now this is the old way of declaring. So when I wrote this code, it was like before .NET 2.0, plus equals new water level event handler. And in some ways, this method of declaring event handlers was a little bit more straightforward. But nowadays, you can just do this, right? Well, you don't have to say new and then the delegate type. You can just say plus equals its pump, right? And then give it the name of the event handler method. So this method of assigning the event handler is exactly equivalent to this method, right? Nowadays, this is the new method, and I say this is the shorthand method, and this is the longhand method of assigning an event handler, and both of them work, right? They're both valid ways of doing it. Let me save that. So now I create the low level sensor object, and I set the mode to be the low level indicator, and then I assign the drain. So here I've got, let me go back up here to the high level. I've got states, fill, right? So there's a fill tank event handler. So as the tank is filling, the high level sensor will respond, the fill will respond to these fill tank event handler with a fill, the fill tank event handler for its pump, right? Its pump fill tank event handler will respond to a fill event. Then we have a full event, right, for the high-level sensor. So when the high-level sensor fires the full event, the pump has a full tank event handler, which will then respond. All right. Now water. So you can think water is going up and up and up and up. The water's coming in, it's going up. And now for the low level sensor, now when we start draining, we have a drain event. So as the tank is draining, this drain event fires. And once it gets to a certain point, the empty point, okay, then the empty tank event handler fires. When it's draining, its pump drain tank event handler responds to that event. Then we have another method. Change water level. I can change the water level. This allows me to, this changes the visual, well, I have this change water level method, and the low level sensor change water level, and then the high level sensor change water level. And then I say water level equals underscore current water level plus equals amount. And then last water level equals current water level. And then this dot change visual level. So there's a change visual level. I'm not even going to really review that method, only because I think it's a hack, but it was something that, served. And then I put in a delay. Now this delay was so you could actually see the event of the drain and the fill, because if you didn't, it would just like, boop, it would fill and drain. You wouldn't see any like animation. So I put a little delay in there, and I could probably do it without necessarily having a for statement that just does nothing, right? I could probably do it with a thread and say, okay, once you do this, then sleep for 15 seconds or sleep for a half a minute so that you can see the event, right? There's 16 ways to skin a cat, essentially. And I'm sorry for you cat lovers out there. But Bjorn Strustrup said that, the guy who invented C++, I believe is a quote of his. And he's right, in this business, there's 15 ways to do, or 16 ways to do just about everything that you want to do. So what I find is my first inclination is to do brute force programming. And then my next inclination is to go back and then optimize later. I usually find I don't write optimized code right off the top of my head. That was the water tank. So that's the 10,000 foot view of the water tank. Let's go back to the diagram. So we just covered this class right here. Let's cover the pump class. All right, so let's return to the code. and we'll call it pump. Okay. So we have a pump class, public system pump. There's no real graphics functionality with this. It's just a class with that just does pump stuff, right? So we have private int pumping capacity and its tank. So what it has is it's got a reference to the tank that it belongs to, right? Well, because the tank has the water level and it has to monitor the changes in the water level in the tank, right? So we can add, then I have a property called pumping capacity where I can read and write the pumping capacity of the pump. And then when I create, here's my constructor. When I actually create a pump, I give it a water tank, right? And then I give it the pumping capacity. Then I have a full tank event handler. Okay. Now what happens is, if the tank is full, right? Once it gets full, and the tank fires the water level indicator, right? The water level indicator indicates that the tank is full. Then the pump will then say, all right, and this is how I'm making the pump, look like it's pumping. Its tank dot change water level, all right. Its tank dot change water level is going to then subtract the amount of the pumping capacity. Now, you could have done this a couple different ways, right? When I do this, I'm just saying, all right, subtract 1,000 from however much this pump pumps, right? So admittedly, this is a very straightforward, and you might even say naive implementation, right? There's no granularity to it. You could change the granularity of the pump, but this pump pumps 1,000 units per time, and I have not defined what the units are in particular and how much time it takes, right? The time is instant. In other words, all right, it's full, boom, it reduces it by X amount, right? So in that particular regard, it's not realistic, but really, again, like I say, the whole point is to demonstrate the handlers, the event handlers, and the custom events. Now notice when I actually fire this, right, it only expects the water level event args, right? So the water level event args pulls in the amount of water, and I don't use it in every method, okay? Although every event handler expects a water level event args because that's the signature of the delegate. But if we go down here to the empty tank handler, right? I pull in the water level event args, and then I say console.write empty tank event handler, and then write line, water tank has been drained, all right? So I put these trace messages in there so we can say, okay, this is the full tank event handler. This is the empty tank event handler. And then when the empty tank event handler fires, I add another message that says water tank has been drained, the water tank contains, and then I get E water level from this water level event args. And I'm using gallons. It could be anything, right, at this point. Now the fill tank event handler, fill tank event handler, the water tank contains, and I just report. So as the water rises, in other words, whenever there's a change in water level, the fill tank, as the water level's rising, and then as the water level drains, okay, it fires the drain tank event handler. And then all it does is, right, it prints, well, in this case, as the water's filling up here in this method, it just prints out the water level. But if I keep on saying drain, whenever I call the drain tank event handler, I'm actually subtracting the pumping capacity, right? So let's go. So you might be asking, well, okay, so what's happening here? Let's go to, there's a trigger, actually. So what happens is I fill. Let's go back to the program. I add water, 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 I add water. Okay, so when I add water, the fill tank, right? The fill tank event handler fires. So let's see that output over here. fill tank event handler, water tank contains, right? Water tank contains. So let's go ahead and do it this way. I add water, fill tank event handler, add water, fill tank event handler. And then it gets up to a certain point, which is 8, right? And then the next time I hit that, it gets to 9, which is 1,000 gallons away from full, which is my set point that then says, oh, full tank. I've triggered the full tank event handler. I'm draining the tank. And then when I'm draining the tank just continues to drain. In other words, I got a pump, and the pump, the pump is just sitting there, right? And the pump's purpose is to drain the tank, really, in this case, right? This button here simulates, just, hey, I'm adding water to the tank. Then as the tank reaches a certain state, a full state, it triggers the pump to start pumping, and the pump will say drain tank. So as the full event makes the pump start, and then if the pump says, oh, I haven't reached my low set point for that's my low event, my low level indicator is keeping tabs on that how much water's in the tank, it will continue to fire the drain tank event handler and say, I need to keep draining, which then subtracts water from the tank, like that. All right, so that's your pump. The pump is, it really has just the event handlers in there to actually, make the pump do its job. Back to the code. Now let's take a look at the water level sensor class. And this class has a little bit more going on. It has an enumeration, and it can be either high level indicator or low level indicator. I give it a set point. It keeps track of the current level of the tank, whether or not it's rising, right? And then there's the mode, right? So I'm setting, here's the mode enum, and the water level sensor has a mode that it operates in. So I initialize the mode and say, all right, it's a high level indicator, and then you can change the mode, right? So that's just the default mode. Now I have 4 events, and these events are in the form of, or the type, delegate water level event handler. So there's my custom delegate water level event handler. There's my event keyword, and here's my full event, my empty event, my fill event, and my drain event. I can set the set point of my water level indicator. I can set the current level. These are properties, read, write. I can set the mode or sensor mode. And then I have another method called water level sensor. Well, this is the constructor, right? Water level sensor is my constructor. And the reason, you can tell that out of the bat, it doesn't return a type, right? I really should have comments and regions around here. I just don't. I wrote this code so long ago. Water level sensor constructor. I create a water level sensor with a set point and a current level. All right. So there's a set point equals underscore set point, and underscore current level equals current level. Now the change water level method. So this is the custom method that fires the vents, right? So last level equals current level plus equals amount. So I'm changing the water level. This could be positive or negative. So it's rising, right, which is a Boolean value, if the current level is greater than or equal to the last level. All right, so I'll just say I just call it rising, right? Switch mode. So if I'm a low level indicator or a high level, if I'm a high level indicator, if I'm in the high level indicator mode, right? And if the current, if it's rising, if rising is true, right? If the water is rising, and if the current level is greater than or equal to the set point, then water event args equals new water event args current level. So give it the current level, and then on full So that's a method that's declared down here. So here's the method that fires. On full. So in other words, if my current level is greater than or equal to my set point. So whatever, if I'm operating in the high level indicator mode and the water was rising and the current level is greater than the set point or equal to it, then, hey, the tank is full according to this program's parameters, right? Trigger the on full event. So I come down here, here's my on full. On full, and I pass in the water level event args, right, which is what I do up here. So that's where I create that new water level event args, and I call the on full event. I'm calling the event, right? I'm triggering the event. Actually, I'm calling the on full method. The on full method then says if the event is not equal to null, which means, hey, if there is a subscriber to this event, then trigger the event and pass in the water level event args parameter E to that event. And then the event goes out, the event calls the method, the event handler method that's interested in the full event. It could be one method, or in this case of this program, it's just one method. Or it could be multiple methods, right? Depending on your application and what you need. And then here's the empty event, right? So what happens? So else, if the current level is not greater than or equal to the set point, then the water, but the water's rising, but it hasn't got to the top, then the water level event arg, create the water level event args. I could rewrite this code and just create this once, but like I say, sometimes you just brute force the solution, and then you go back and look at it years later and go, boy, that I could do better. All right, I'm sure a lot of us have that feeling. Then you call the onFill method, and the onFill method then says, hey, if the fill event is not equal to null, call the fill. So in other words, I'm calling the fill event handler. I'm triggering the fill event handler, fill event, which then calls the fill event handler in the pump, right? Okay, so the next mode is that, well, if I'm not a high level indicator, then I'm a low level indicator mode. If it's not rising, just to make sure, right? If water is not rising, that means it's got to be falling, right? All right. Then if current level is less than equal to set point, right? In other words, if I'm in the low level indicator mode, then my set point would be, I'm looking for the set point to be, I'm looking for the current level to be equal to or less than the set point at this point, not greater than or equal to. Then create my water level event args, right? And blah, blah. And then on empty, I go down here to on empty. Then I trigger the event. I say, well, if the empty event's not null, then that's the empty event. Like that, right? On drain. So if it's not less than the set point and the water's not rising, then that means it's in the middle of going down. Then it's draining still, right? So call the drain. So here we go. We go back here, and if we pull up the app, we add water, fill tank, fill. So we have to come up here, fill, here's the fill, these are the fill, those are the fill events, there's the full event, here's the drain events, and here are the empty, that's the empty event, empty tank event handler, empty event. Okay, the delegate. Okay, so we went over the biggest pieces of the puzzle. Let's look at the small pieces of the puzzle. Let's go back to the code, and that would be we can start with the event args, the water level event args, which it just extends the event args. So in the system namespace, you have the event args. And if you've done GUI programming, the event args is like if you click on a button, it's the event args class that gets passed in, right? So I've just extend that class, and I create my own custom event args and call it water level event args. It has a private field, water level. I have a constructor, and I have a property, so I can get and set or read and write the water level. And I use this class to pass in the water level to my methods, right? My event handlers. I go back to the code and I go to the delegate. This is my water level event handler, delegate. So public delegate, right? the method takes returns nothing, right? It's void. Returns void. The name of the handler, the name of the delegate is water level event handler, and whatever event handler method you create has to have one argument only, right? Water level event args. And that's the code, really, right there. Let's go back and check that app out one more time. So it's just demonstrating custom events. You can add custom events to your programs and make, to animate things and have it more of a modular design, right? So where can you, get custom events? They come in so handy all the time for different things, right? You want to monitor the directory. You want to see if a file gets dropped in, and you want to do special event processing. Well, they actually have, I think they got classes in the IO namespace that do that, events are everywhere, right? If I add a collection, if I add something to a collection, the collection can notify me that something's been added to it. And the notification can do something as simple as write a message to a log, write a message to the console, or trigger an email event. I mean, you name it, right? It could start a chain reaction which could bring down entire networks. Who knows, right? Your imagination is the limit. But custom events are cool, right? All right. Now my computer's locking up. There's no telling with Microsoft, Windows 10, right? Okay, so that's it for custom events. Again, my name is Rick Miller. If you have any questions, once again, this code, this lecture material came from Chapter 13 of my book, C# for Artists, The Art, Philosophy, and Science of Object-Oriented Programming, 2nd edition. Get your copy today from Pulp Free Press. Let me take a zoom out here on this cover. Boom. All right, that's a little better. All right. Chapter 13, Custom Event Processing. All right. Custom Events. And it's the section on the automated water tank. And I will zoom in here. Custom Events, Automated Water Tank System, and how to respond to events. All right, so if there's, like I say, any questions, rick@pulpfreepress.com, and I appreciate your attention today. Have a great day, and happy programming.